system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
Type of supports and types of beams, because we'll be coming across situations where there will be one type of beam and there will be other type of load. There will be no constant beam, there will be no constant load in itself. Now before I move in, Satyabrat have asked, can I see the class some other time? Yes, Satyabrat, you can see the class some other time. What you have to do is you have to go to www.anilnayarclasses.com. Okay, anilnayarclasses.com. Go there, go to contact us. There a number will be there. You call that number and ask for the same recording, that live class recording. You ask them. Okay, fine. Anyway, I'll continue this. So type of loads. So type of loads on this are basically here. The first type of load is point load. I'll discuss in detail, just keep patience. Point load. Then we have UDL, that is uniform distributed load. Then we have UVL, that is uniform varying load. This is type of loads. Similarly, when you go for the type of supports, one is hinged, then we have simple supported, then we have roller support. Any other support? Come on, I want you to type. You can type here any other support if it is there. Pin support. You can say pin support, right? So next one is pin support. Similarly, when we come to type of beams, here type of beams, the first one we can say is cantilever support, cantilever beams we can say, right? What other beams? Cantilever. Then we have simple supported, we have continuous, we have overhanging, we have fixed, and we have cantilever as well as simple supported, correct or not? So they are cantilever, fixed support beams, then we have simple supported beams, then we have continuous beams, then we have overhanging beams, and we have cantilever and simple supported beams. Right? Now to understand this, let me go in detail of all. So first is type of loads. So point load. Before coming to load, let me start with beams first, so that it will be clear one by one. Okay, cantilever beams means, if say this is a wall, and this wall I have fixed a beam whose one end is fixed in a wall and the other end is hanging. So when the other end is hanging, what happens? This will have its own load, and because of load there will be a force acting at the edge, correct? It may be on the upper side, which may be down side, doesn't matter. But thing is, obviously when it is an open beam, the force will be acting downwards by default. Because why? Because weight always acts towards ground, that is because of gravity. So force is nothing but, weight is nothing but a force, so force will be always acting down. So this is what this is called as cantilever beam, when a beam is fixed at one side and left free end at the other side, that is called as cantilever beam. Whereas fixed support is the same beam which I have fixed at one end, now I'll fix at the other end as well. In that case, it is called as fixed support beams. Similarly, when I go for simple supported beams, how simple supported beams will be? One end will be connected with a hinge and one end with roller support. So this is what? This is beam, right? This is simple supported. So this was cantilever beam, this was fixed support beam, this is simple supported beam. Next we'll go for continuous beams. So continuous beams are what? It will be continuing. That is, if I take the same simple beam, so it is very long. This is a beam. Say this edge is connected with a roller support. In the same time, there are also supports in between. So this is called as continuous support beams or continuous beams. Similarly, overhanging beams. So overhanging means, the name itself suggests overhanging. It means if I take two supports, say this is two roller supports, over this there is a beam. You can see on the left side and as well as on the right side there are no support at the edge. So this is called as overhanging beams. And the last one, cantilever and simple supported. Cantilever means what? Whose one end is fixed, and simple supported means whose other end is with a either with a hinge support or with a roller support, correct or not? So this was all about cantilever beams. This was cantilever beams. Fixed support, this was fixed support. Simple supported beams, continuous beams, overhanging beams, and finally cantilever and simple supported beams. So this was what? This was types of, these were types of beams. Now coming to type of supports. If we come to type of support, first one is a hinged one. Hinged means if a body is supported by this hinge support, what does it really mean? It means this body can travel in this direction, that is this, right? So it means what? We can also say this as a pin support. So hinge support is also called as pin support. So not to differentiate with this. So hinge support at times also called as pin support. So this, if this kind of beams are there, then this will be converted to two reaction forces. That is, for example, this was given force, say this is a hinge support given and a force is given like this at a distance d. So when you remove this hinge support with a reaction force, there will be two reactions acting on it. One is reaction at vertical, one is reaction at horizontal. Similarly, coming to simple supported, here in simple supported what happens is, if I take a same beam such that one side is connected to a hinge support, one side is supported to a hinge support and the other side is supported with a roller support. Now here if I change, then the reaction forces on this will be reaction because of vertical and a reaction because of horizontal. Similarly, in case of roller support, when I change this roller support to a free body diagram, this will be a vertical reactions again, right? So this was what? This was simple supported. Now coming to roller support. So you can see already I have shown roller support. Roller support, there will be only one reaction force. That is, if this is a body, this is supported with a roller support, and if I want to convert this roller support into a reaction force, then there will be only one reaction, that is on the vertical side. There will be no horizontal forces, right? Now apart from this, I can also add one more support, that is fixed end support. Fixed end support. Now what is this fixed end support? Here, say this is a cantilever beam. Fixed end means cantilever beam, right? Now this cantilever beam, if I want to replace this fixed part into, in terms of reaction, what all things will be getting converted? So here there will be one force, that is one reaction force in the vertical side, there will be one horizontal force, as well as there will be one moment. So what we understood, when we replace a fixed end, the fixed end get converted to three reaction forces, that is vertical, horizontal, as well as one additional moment. So these are very, very important, because if you don't understand this basics, it will be very difficult to understand the other stuffs. Okay, so here these are what? These are the nothing but types of supports. Those are hinged, simple, roller, pin and fixed supports, right? Now after this, let's come to loads. So I'll remove the other parts. I hope this is all clear to all now, so that I can make it, I can bring more space into the board. So here, when we discuss about loads, I have defined three loads, right? That is point load, UDL and UVL. I'll take a simple example, and through that I'll make you understand this. Say I'll take a cantilever beam. Okay. Say this is a cantilever beam I have taken, whose one end is fixed, and this beam of length L, let's say, okay, is carrying a load F at a certain point. So whenever there is one single load at a certain point, that particular point, that particular load is called as point load. Okay, now let me divide into some following spaces. Say this is 1 meter length, this is 2 meter length, this is 3 meter length. Okay, now here what I'll do is I'll replace this. Here I'll put it okay. Now here, say this force is so I'll write it 1, 2 and 3. So 1 is what? Point load, 2 is uniform distributed load, 3 is uniform varying load. Uniform distributed means throughout the length of 1 meter the load is same. It is acting at every point, the load acting is same. You go to 0.1 meter, 0.2 meter, 0.3 meter, over this we will find the load as same. Now this is 1, 2, 3. So 1, 2, 3 is nothing but 1 is for point load, 2. Now I'll give the load. Say this force is 10 kilonewton. This force is 20 kilonewton per meter. Kilonewton per meter. Similarly, say this is 30 kilonewton per meter. So in this case, if I have to convert this into a free body diagram, what it will be, say this is A, this is B, this is C, this is D. Now if I convert this, what happens is, here A, there will be, this is a cantilever beam, so it will be converted, it will be replaced with reaction forces, correct? 3 reaction forces. Say this is RA, or I'll write it better, HA, that is horizontal reaction force, this is VA, that is vertical force, and this is say MA, that is moment A. Here this is B. I'll take little more distance so that it will be clear. This is B, this is C, and this is D. Now if I want to replace these forces into one common force, how I'll replace it? This is a load, that is point load, right? So this is a point load at 10 kilonewton. Now this load, what will be this load? Here this is like a triangle. So when this is like a triangle, uniform varying load, how to understand uniform varying load? How to understand uniform varying load is, here if you see this varying load, this is a length and the load is varying continuously, means the load is something over here, say this is 3 meter, this was, so at this point the load is different, 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 at this point the load is different. If you see all together it looks like a triangle. So where the load, the maximum load here is 20, whereas the minimum load here it is 0. This is 20 kilonewton per meter, means the highest load over here is 20 kilonewton and the lowest, that is at this point, at this junction, the load is 0 kilonewton. So when we see this, this looks like a triangle, correct? When this looks like a triangle with a height as well as base, here height is how much? 20, base is how much? 3. And we know the area of triangle is what? Half base into altitude. So that is half, base is 3 and altitude is 20. So 2, 1, 0 gone. So this is how much? 30. So this 30 is nothing but this is the load kilonewton per meter. This is the load, that 30 kilonewton per meter, which acts at the center of gravity of this particular triangular shaped force. Means here this is a triangle shape, so the center of gravity, so the center of gravity for a triangle will be what? This is a triangle, right? So the center of gravity will be somewhere here, correct? So it means what? At this center of gravity, the total force acts. What is that force? 30 kilonewton per meter. So in simple, I can say 30 kilonewton at this load. At a distance of what? At a distance of this total length, say this is 3, say this is 3, so this is B. So this will be B by 3, whereas this distance will be 2B by 3. Similarly, if I go by this distance, say this is h total, so this distance will be 2h by 3, whereas this minimum distance will be h by 3, correct? So this is what? This is nothing but the center of gravity of the uniform varying load. So in this case, you see B by 3. So what is the base here? So this is C at a distance of B by 3, that is 3 by 3, and this is 2B by 3, correct? This is what? B by 3, this is 2B by 3. So this load, how much load? 20, half into 3 into 10, that is half into 3 into 20 will give 30 kilonewton. So 30 kilonewton will be acting at this point from the force, correct? If we go to measure from this side, from 10 kilonewton side, from D, then it will be at a distance of 2B by 3. If you go from the point of C, it will be B by 3. Similarly, we have one more load, that is A to B. Now A to B, if you see, that is what? Uniformly distributed load. What is the load over there? The load is 30 kilonewton per meter. So 30 kilonewton per meter means exactly at center, the force which will be acting is force into length, that is 30 into 1. So this is 30 kilonewton, whereas this 30 was actually half 3 into 20. In uniform distributed load, this will be acting exactly at the middle. That is A to B is 1. So exactly at the middle of it, the force will be acting. That is force into length. I hope this is clear to everyone, right? So this was all.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free, AMC.